Hello, welcome to the lecture series on automobile engineering. Now we'll consider module 3. So far we have discussed module 2 and module 1. Now in this module 3, basically we deal about importance of wheel geometry and wheel alignment, steering principle and various steering systems, the need for suspension and various types of suspension systems. In addition, we'll also consider illustration of ignition systems that are used in modern automobiles, which I could have dealt in module 1 itself. First, let us start with wheel geometry and wheel alignment. Basically, in the car, you can see there, our idea is while running the car, the wheel should remain perpendicular to the ground and the wheels should be parallel to each other. So we say that a wheel alignment consists of adjusting the angles, various angles of the wheel so that they are perpendicular to the ground and parallel to each other. So the purpose of this adjustment is to have maximum tire life and a vehicle that tracks straight and true when driving along a straight and level ground or level road. Basically, if you see here, the wheel, then this you call it as steering knuckle, okay, knuckle. We have the steering knuckle. Then this is the frame of the vehicle. To this frame of the vehicle, the wheel has been suspended. So here I am using one suspension linkage that I call it as lower control arm, and this one is a MacPherson strut. So for understanding, let us call this as upper control arm. Okay, then to the steering knuckle we have steering link. Of course, this steering link will be connected to rack and pinion arrangement. Then we'll have a steering column and steering wheel like this. So when I steer this like this, so the wheel may turn this way. When steer like this, the wheel may turn this way. Now here we have joint here, joints here, joints here, and so on like this. So what angle that I should maintain in this, or what geometry we should maintain when the vehicle is unladen and stationary condition, so that when the vehicle is loaded and also the vehicle is moving, the wheels will remain perpendicular to the ground and also parallel to each other. That is a kind of thing. That's what we are talking about. So those angles is what we call it as the wheel geometry. Now this we can understand with a beautiful video, but I am not going to record this video. There are many videos available on the YouTube. You can type the password wheel geometry, wheel angles, keyword, and number of videos appear. You can click whichever video you like and you can understand the wheel geometry and the steering system. Now, if there are any changes in the change, so though we adjust the angles and set the system, but however with the time there will be changes in the wheel alignment. The changes happen because of wear of the steering and suspension components. If you see here, I'm using bushes. After some time, the bushes may lose their mechanical properties. Some kind of a play might creep in. Same here also. Or due to some reason, these linkages may get damaged. And wear and tear of the tire might happen. Because of all these reasons, wear of the steering and suspension components, bent or damaged steering or suspension part, or sagging springs which can change the ride height of the vehicle and therefore the alignment angles may change. So if the alignment angle change, what really happens? So when you start steering, you may experience pull. What is that pull? Is defined as a definite tug on the steering wheel toward the left or right while driving straight on a level road. Suppose this is your vehicle. Correct. So while steering, the vehicle may start pulling towards left or pulling towards right depending upon which wheel alignment angles are changed. So it's a real, there will be a force and we have to counter this continuously using our steering system. So it will start generating pull. It may make the vehicle unstable sometime. Correct? That is a basic problem. Suppose you are running on a cambered or a road with crown and all that. It may start drifting. What is the drifting means? It's a mild pull that does not cause a force on the steering wheel that the driver must counteract. Here we have to do. When the vehicle moves towards on one side or the other, this is called lead or drift, could be caused by the crown of the road, etc. Another thing that can happen is wander. Say something like continuously your steering wheel, so it will go like this. You continuously have to correct like this. Is a condition in which almost constant steering wheel corrections by the driver are necessary to maintain straight ahead direction. So if the alignment angles change, these are the kind of problems that you face. Not only that, so even this uneven wearing of tires also will happen. So hence it is necessary, we need to maintain manufacturer specified alignment angles. If that is the case, what are those alignment angles? Let us look at. One of the angle that is important is camber. What is camber? Look here, let me put the tire straight, that is perpendicular to the ground. Midpoint of this tire, which is in contact with the ground. From there, let me draw a vertical line. And also draw the center line of the tire. That center line and vertical line, they are just coinciding here. Now, if you look at here, from this center point, I draw a vertical line. So you can call it as the line through which the weight will be acting. Then the center line of the tire you take. Okay, it will make an angle. Here also you can see that the same way. Vertical line from the point, midpoint where it makes contact with the ground. Also the line which passes through the width of the tire, then it will create an angle. Okay, this angle I call it as camber angle. Now if you consider this is the center of the vehicle, correct, center line, this I call it as inside, this I call it as outside. Okay, so center line of the vehicle. Now it is tilted outwards. This I call it as positive camber. Here it is tilted inwards. I call it as a negative camber. Correct? You can see this. See, if this is the tires. Correct? Now you see the front view of the vehicle. Front view. When you see the vehicle from the front, then you may see that, sorry, these are the vertical lines. If the wheels would have tilted either outwards, then they will have positive camber. If they tilt little inwards, then we will have negative camber. That's what it means. So you have to see always from the front. So front view of the vehicle. Okay, so camber is the inward or outward tilt of the wheels from true vertical as viewed from the front or rear of the vehicle. Hope the point is very clear. So that angle we call it as camber angle. And positive camber, negative camber, zero camber. So whatever I explained, once again I have written down there. If the top of the tire is tilted out, then camber is positive. Top of the tire is tilted in, then camber is negative. The tilt of the wheel is truly vertical, then camber is 0. And we measure in degrees. Whether it's 1 degree, 1.5 degree or 2 degree, whatever it is, we will see that later. I'll give the specifications. And as I mentioned already, excessive positive camber causes, see, tire wear, scuffing and wear on the outside edge of the tire. So what it means is, you can observe here I have given positive camber. So this portion is scrubbing, right? So here you will find too much of wear. If it is negative camber, here you can find too much of wear, because this is contact is much more with the ground than this one. So also here. So excessive positive camber causes scuffing and wear on the outside edge of the tire. Excessive negative camber causes scuffing and wear on the inside edge of the tire, which is very clear from the explanation. Now I just taken the photograph of a tractor. You can see, if let me put this as a midpoint here. Let me draw a vertical line. Sorry, a vertical line. Then I draw a line passing through the center of this, like this. You can see that it has tilted outwards. This is positive camber. Here also I can do the same. I can find a positive camber. It is necessary that the camber on the left and the right, not necessarily, like it is desirable that positive camber on both the wheels remain the same. Definitely there will be small variation because of, like, various reasons which I do not want to deal with now. So there will be, it is preferred like same angle and all that. Okay, right, sir. Now you can, here also you can observe that positive camber. So now many vehicle manufacturers specify or adjust, they will have positive camber on vehicles. Why that? I have just drawn the three views of the vehicle here. Let us see the front view of the vehicle. So you have suspension and all that. In the unladen condition, if at all it is having a positive camber, the wheel would tilt like this a little bit, depending on the camber angle, like this. But the moment it is loaded, this suspension system will push this so that they become vertical. So that while running, they remain vertical. That's the kind. So when the spring sack camber usually decreases, as the vehicle is loaded, or when the spring sack's camber usually decreases. If camber is kept positive, then the running camber is kept near 0 degrees for best tire life, so that there will be a uniform contact with the ground. So that's the idea, positive. But there are cars with slightly negative camber also, right? Camber design. So now the next, there is what we call it as a camber thrust. What is that? So let us say we are given a positive camber. The vehicle is, like, taking, let's say, turn or whatever it is. So now the question is, you can see that because of this camber, right, there is a reaction force acting in the outward direction. So when it starts rotating, say it will be pulling inside. For that, there will be a reaction outside, opposite to this. Okay, this reaction is what you call it as camber thrust. Correct? So to compensate the reaction, a camber thrust will be active. So camber thrust will always act in a direction towards which the wheel is tilted. That means the positive camber, it is this. So it will create some kind of, what you can call it as, a lateral force. This lateral force, I call it as camber thrust. So you can imagine a cone is rotating, it's trying to slide like this. So to oppose that, there is going to be a reaction force. Here, this lateral force or camber thrust versus camber angle has been drawn. So what's the kind of, for the camber angle, what is the kind of thrust or lateral force it can produce? You can take from here. So this is what I was just explaining, how exactly a camber thrust is created. This is what has been written over here. So camber changes dynamically during dynamic conditions. So let us say this is the initial, wheel position. This is the upper control arm of the suspension. This is the lower control arm of the suspension. If I just produce these two, they will meet at one point. Let me call it as instantaneous center. So now you just imagine the vertical direction. Suppose this vehicle is taking a turn like this. This is the right side or outside, and this is inside. So again, you will also have the same kind of condition like this. There is going to be a lateral load transfer from left to right. This is what exactly I have shown, force. Because of this load transfer, it may assume a new position. That's what exactly I said, camber changes. So here, so it is like this. And the more load gets transferred to this, it may get compressed, the suspension. So then the wheel may tilt, outwards. This wheel may tilt little inwards because it gets released like this. So that way it is going to change. Camber changes during dynamic conditions. Whenever you are taking a turn, because of the load transfers, lateral load transfer, camber changes. But so moment you change the camber, it is, if there is a too much of a camber change, then what is going to happen? Then there is going to be a larger lateral force on this side. There will be a smaller lateral force on this side. There is a chance the vehicle will start pulling that side. Okay, now what exactly happens? Let us see now. So this is what I am calling it as an independent suspension. So here you can see frame. Relative to this frame, I have fixed the wheel. The wheel will move relative to this, up and down. If it is moving up, it will not really interfere with this. Means this is independent. This motion of this wheel with respect to this independent of this. Okay, you can call it as an independent suspension also. But if it is a solid one, it is different. By chance, it is the static condition. If it moves over a bump, the whole thing gets lifted up. Again, it comes back like this. Okay, here, because of this, it will happen. Not much with the dynamic conditions and all. But with the independent suspension, there will be a considerable camber change. Okay, I'll just come back to this 1 minute. Now the thing is, what is the effect of those camber change on handling of the vehicle? What do you mean by handling of the vehicle? Suppose this is the vehicle. I am just taking a turn. Let us say the vehicle intended path is this. When I steer, this is my intended path. By chance, after giving the required steering input, theoretically calculated input I have given, this is what exactly it should follow. When I give that theoretically, so it will not follow this path. Instead of that, it may start following this path. So to bring it to this path, I have to steer more. This I call it as understeer condition. Correct. Suppose I have to steer less. Instead of that, the vehicle takes a turn like this. Then I call it as a oversteer condition. So this might, both the conditions, you must be extremely, too much understeer also, I need to be extremely careful. I need to put in a lot of effort to make the vehicle follow the desired path. Here, without putting much effort on its own, it might turn dangerous. So need to be careful. Now the question is, if at all, if you have a positive camber, you are taking a turn, and this is inside, it is outside, there is a load transfer. Because of the load transfer, the camber angle may change. It will become too positive. Then what is going to happen? There will be equal side forces should be there. This will decrease and this will increase, and it will start pulling the vehicle like this. This force about this center of gravity might create a counterclockwise torque. So it will pull. That's why then you have to steer more. This is what really happens. If you would provide a negative camber, then vehicle might oversteer. So these are the kind of effect the camber. So we must be very, very careful. That means basically this wheel is suspended. That means the suspension system has to be carefully designed so that the camber changes are well within the limits. That's a very important thing, right? So now, so in the station, as I said, because of more wear and tear, camber might change. Quite often we go for wheel alignment of the vehicle. During wheel alignment, so the people like the mechanics try to maintain original camber angle. So some cars they may not have provided any made any provision for camber change, but it is some places some cars camber can be adjusted by moving upper and lower control arm or strut assembly by means of another like shims, eccentric cams, and slot and all that. Another very important thing is that camber should be equal on both sides. However, if camber cannot be adjusted exactly equal, make certain that there is more camber on the front of the left side to help compensate for the road crown. Half a degree in LH. What should be the camber angle at the end of this? All the angles. I will give you a specification sheet. Okay. So this is all about the camber, but suspension. It will all lead to the design of suspension. So how exactly a suspension has to be designed to maintain the required camber. So we will discuss another important wheel geometry in the next video. So till then, thank you very much.